Hello, welcome back to online physics lesson. Today we will see uniform motion and non-uniform motion. Let us define the first one, uniform motion. What is the definition? How we define uniform motion? Is defined as the motion of an object in which the object in a straight line. The object moves on straight line, okay, and its velocity remains constant along that line as it covers equal distance in equal interval of time respect to the duration of the time. Let us see the following graph. Here we have distance versus time graph. The time is on the x-axis and the distance is on the y-axis, and the distance is measured in meter and the time is measured in second. Let us consider this 1, 2, 3 points, these points, and let us calculate the speed or the velocity at each point. Let's consider at point 1. At point 1, at this point, we have the time is equal to 1 second. The distance or the displacement is equal to 10 meter. Then let us calculate the velocity or the speed, which is equal to distance over time, which is equal to 10 meter over 1 second, which is equal to 10 meter per second. Okay, at point 1. Let us consider at point 2. At point 2, we have the time. How many seconds? Here we have 2 seconds. And the corresponding distance, how much? 20 meters. 20 meters. The velocity or the speed is distance over time, which is equal to 20 meters over 2 seconds, which is equal to 10 meters per second, equal at point 1 and at point the last. Let us see at point 3. At point 3, we have, let's case see at point 3, we have the time 5 seconds and the corresponding, the time at point 3 here is 5 seconds and the corresponding distance is 50 meters. Distance is equal to 50 meters. Now the speed or the velocity is distance over time, which is equal to 50 meters over 5 seconds, which is equal to again 10 meters per second. At each point, here point 1, point 2, point 3, we have equal speed or velocity. Such kind of motion we call it uniform motion. Even you can calculate at this point its distance over time. How much? 30 over 3, 10 meters per second. Again here 40 over 4 seconds, 10 meters. the speed is constant. Example of uniform motion. Here it's written if the speed of the car is 10 meters per second, means that the car covers 10 meters in 1 second. The speed is constant every second. The other example of uniform motion is movement of blades of a ceiling fan. A fan, already the fan, already fan that cools or our home during hot season. The fan rotates with a constant speed unless we increase the voltage. But in general, once we switch on the fan, it rotates in constant speed. Oh, okay, that's good. What's next? The next point is non-uniform motion. Non-uniform motion. This non-uniform motion, in general, the speed is not, or the velocity is not constant. In the case of non-uniform motion, the speed or the velocity is not constant. That means, let us consider this graph. At 10, the distance, this is the distance time graph. At 10 meter, the corresponding time is at 10 meter, at distance is equal to 10 meter, the corresponding time is 2 seconds. Again, at 20 seconds, the corresponding time is 3 meters. Let us calculate. Let's say this is 0.1 and this is 0.2. Let us calculate the speed and all the, let's, in the case of at 0.1, we have distance 10 meter, and the corresponding time, how much? The corresponding, it's in seconds, or here it's in second, okay? 2 seconds. 2 seconds. Then the velocity or the speed is equal to distance over time, which is equal to 10 meter over 2 seconds. It is equal to 5 meter per second. Okay. At point 2, we have distance and time, which is equal to, the distance covered is 20 meters and the corresponding time is 3 seconds. Distance 20 meters and the corresponding time is 3 seconds. Let us calculate the speed or the velocity is equal to distance over time. It is equal to 20 meters over 3 seconds, which is equal to around this 20 by 3, around 6.66 meter per second is point. Look at the distance, the velocity or the speed varies here at point 1, 5, then 6.6, not equal to 5. This kind of motion we call it non-uniform motion. Alright, let us solve this problem or exercise. If Shantan was able to travel 5 kilometers north, look, 5 kilometers north. This is the displacement. We have given indirectly the displacement 5 kilometers north in 1 hour. The time is 1 hour in his car. What was his average velocity? Write the answer in meter per second. Look, we have given the displacement in kilometer for the north and the time given in hour. Let's look at the solution. When you get problem, the first thing, write the given things given. The displacement is equal to how much? Look, it's 5 kilometers towards north. 5 kilometers towards north, and the time is how much? It's 1 hour. 1 hour. You are required. What's required? What was his average velocity? Write the answer in meter per second. Required the average velocity is equal to how much? In meter per second. Let us write the solution. You have to write the solution. Okay? When you get exercise, any question, any physics question, take out the given quantities, then take out the required thing and write the solution. The average velocity, according to, is the total distance traveled, the displacement traveled over the time, which is equal to 5 kilometers over 1 hour. Alright, now this is equal to 5 kilometers per hour towards north, but we are required in meter per second. So how can you calculate in meter per second? Then we have kilo means 5 times kilo means 1000. We already meter. Let's say the average velocity is equal to over here we have hour. 1 hour, let's convert. Come on here, 1 hour is equal to how many seconds? 1 hour is equal to 60 minutes, which is equal to 60 minutes. How many seconds? 60 times 60 seconds, which is equal to 3600 seconds. The conversion is minor. 3600 seconds, which is equal to around 1.39, which is around 1.39 in meter per second. That's all about today's lesson. See you in another lesson. Until then, bye bye.